In the other video, we looked at how to change fractions into decimal, and we learned how easy to fractions. For example, if you have, sorry for that, if you have 1 over, so let's say you have 1 over 3, so that is basically will give you 0.33. And these ones are recurring. And if you had, so the key was like 1 over 3, 1 over 7, which normally gives us 0.4142857. 1 over 9 will give you 0.111 recurring. 1 over 11 will give you 0.09 recurring, so 0.9. 1 over 13 gives you 0.0769 and 2. And then 1 over 17 will give you 0.0588. And 1 over 19 will give you 0.0526. So these are very essential. So these ones we just worked on the previous video, and now these figures are going to help us a lot when we do the auxiliary fractions. These are fractions that when someone tells you, if you have to work with them, it goes, you can easily do the calculation without taking on, like using a calculator. So I want us to look at this. And also in another video, so we looked at like fractions like 1 over 2, and we know that 1 over 2 is 0.5, and that means like 1 over 4 is just 0.5 squared, because so it can be written as 1 over 2 multiplied by 1 over 2. So that basically means 0.5 squared, which gives you 0.25. So knowing that is going to help us a lot while working with auxiliary fractions. So let's go to the few questions we have here and see how we can calculate. I will take another pen for that case. So here, A, we have 1 over 6. So 1 over 6 is similar to saying 1 over 2 multiplied by 1 over 3. Okay, and we know that 1 over 5, 1 over 2 is equal to 0.5 multiplied by this one we know is 1 over 3 is 0.333. So if you multiply the two, it will give you 0.166. So normally then you leave it at 67. Easy. So that is the most important thing, that every time you are given fractions, you just look whether the fraction, like the number, is a factor of either 2 and 3, or if it's a factor of only 2 and other numbers that are even numbers, or only if it's a factor of prime numbers. That's going to give you easy leverage for you to understand fractions. So it makes everything easier. Now let's look at how we want to deal with B. So 17 over 139. So this can also be written as 17 over 1 multiplied by 1 over 139. The thing is that if we deal with only 139 alone, 139 is only 1 less to give us 140. So how about if we say now we have 17 multiplied by 1 over 40, but that is what we call auxiliary fractions, where now since we don't have 1 here, okay, since we don't have only 1 here and to get 14, the idea is like we'll promote 139 to 140, and then this 0 will then make us go back so that we have 1.7 multiplied by 1 over 14. So this is also easy. The The method we're going to follow here is going to be direct. So let me just carry this from here onward to this side. So we have here 1.7 multiplied by 1/4. So what I'm going to do here is I'm going to still insist on 1/7 and multiply. So we know that 14 is 1/7 multiplied by 1/2. Okay, and 1/7 we know, remember I told you these numbers are going to help us a lot. So we have here 1/7 multiplied by 0.14285 times, then half also we know is 0.5. Okay, so dealing with that becomes a bit interesting and also easier than if we multiply everything, like if we use a calculator. So this one, now you know that anytime you multiply a number by 5, multiply it by 10, divide by 2, and then you multiply. So then our answer is going to be, if you multiply all together, you have 0.124214. Okay, so that one becomes our answer. Without using a calculator, you can easily do that, compute that one without a problem. So that is why it's very important that we use this method to calculate auxiliary fractions. So that means like we are promoting numbers and then just continue. So let's see. Let's go to C and see what C has for us. Okay. So again here, so C is the same. We're going to use the same method. So 98 over 179. Again, here we're going to have 98 over 1 multiplied by 1/179. But we have to promote this 179 to 80. So if we promote, that's going to be 1/80. But this 0 will cancel, so that we have here 9.8. So what we have here is 9.8 multiplied by 1/18. So I'll carry this one and then continue with it here. Have a space here. So now we have 9.8 multiplied by 1/18. Now 1/18, we can, having known, the fractions of 9 and 2, we can also multiply this one easily, get an answer to all this. So this is going to be 9.8 multiplied by 1/9 multiplied by 1/2. We know 1/2 is equal to 0.5. 1/9 is equal to 0.111 recurring. Okay. So in this case, we have 9.8 multiplied by 0.1111 times 0.5. So what do we have? We have here, if you multiply all total, we give you 0.45475. So that is easier way to deal with it. Now I will wrap this and then so that I have the same space for doing D, E, and F. And if you just want to look at it again, you can always pause the video and see how we are doing it. Now, 18 and 73. In this case now, I wanted us to look at 73 to a point where 73 give us a number that ends with 9. Okay, you're going to learn in the next auxiliary fractions where we're going to look at the first type and second type. But this one now we are doing the random calculation of both the first type and second type. So here we have 18. So here we have 18 and 73. But for this 73 to have a 9 at the end, we have to multiply this one by 3. And if we multiply this one by 3, this one also has to be multiplied by 3. So then we have 18 multiplied by 3 will give us 54. And 73 multiplied by 3 will give us 219. Now 219 is just 1 less until we get like 220. So this is going to be 54 multiplied by 1 over 220. Okay, so in this case, what we're going to do, this 0 is going to make this, is going to convert this one to 5.4 multiplied by 1 over 22. Okay, so after doing that, now the next thing we're going to work on is 1 over 22 is easy because this can also be written as 1 over 11 multiplied by 1 over 2. And since we know all the values of this, so we have here 1.4 multiplied by 1 over 11 is 0.0909 recurring. And then we have 1 over 2 is always 0.5. So we want to multiply them. So that if you multiply them, that's when you come up with 0.2454. So easy. So easy approach. You can use that approach to multiply that. So let's say C. Let's look at E. So E is also the same. We have here 1 over 43. Now that one gives us something like, also we want to make 43 to have 9, okay? We want to have 43 to have 9. So what do? We multiply 43 by 3, everything by 3. So we're going to have 3 here over, so this is going to have 9, 129. So we multiply 1 by 3, okay? So here we're going to have, it's going to be 3 multiplied by 1 over 129. But 129 can be converted into 130. Okay, so we're going to have here 3 multiplied by, we promote 129 to 30, so it's going to be 1 over 1 over 130. So 1 over 130 would mean that we put this 0 to bring us 0.3. So here we're going to have 0.3 multiplied by 1 over 13. And if you remember, for us, 1 over 13 is equal, 1 over 13 was, we know the value. So this is going to be 0.33 multiplied by 0.07669. You multiply these two, the answer will be 0.02307. So here also we have 53. So I will put this one, we have 53 over 799, which is going to be basically 53 over 1 multiplied by 1 over 799. At 799 is only 1 to go to 1 over 800, okay? So what we're going to do here is we're going to convert 1 over 177 into 1 over 800. Okay, so this is only a 1 to less for it to become 800. So in that case now, the 2 zeros will cancel. So we're going to have, it will make 53 0.53, 0.53. And then we're going to multiply that one by 1 over 8. Okay, so this is the way to simplify it. 1 over 8 is equal to 1 over 2 multiplied by 1 over 2 multiplied by 1 over 2. Yeah, because this is now 8. But 1 over 2 is 0.5. So basically 0.5 cubed, which is going to give us 0.53 multiplied by 0.125. So we have our answer as 0.06625. Simple, simple, simple like that. And we have our answer. So that is what I wanted to share with you today. Thank you so much for listening. Have a nice time. Bye.